What up, YouTube? Digital. Let me turn this around. 13.1. It's counting down because the LCD circuit is it's got some little sound, little doohickeys. So, yeah. Anywho, this is a capacitor. Now, shit hits the fan, and damn it, I don't want to do this video. I'm being nice. Alright, batteries. First off, that's a capacitor, and we'll get back to it. Let's talk batteries real quick. You might be able to still find 12 volts that you can that you don't need to add the doohickeys later, the sulfuric acid mix. 6 volts definitely, because I got one in there not even 3 months ago. So the problem is you still got to charge the battery after you add that in, so that's a problem. The other problem is well, you shouldn't have too many batteries. If you do like Lambdog said, keep the AC volts out. So you gotta have, good equipment. You gotta keep it charged nicely and everything else. Batteries should last a long time. These are not the same batteries from 1962. The batteries nowadays will last 7 to 10 years. I ran a bank of 12, and half of them were used from semis. Guys was giving them to me for $20 a piece. I'd pop them in there. I don't care. And I'd run them all the time. Now I run mine outside. You never should run any of those batteries inside. Even a gel cell's not a good idea to run it inside. It could blow. Even though it's unlikely, it could overheat. You just don't run that shit inside. There's no reason to. You can run a 4-gauge wire. Matter of fact, I have 12 volts. How I charge this is I got 12 volts right here on my wall. 6.9, 6.8. But I got 12 volts sitting right here at 90 amps, 95 amps. In my old house, I had 12 volts. I had 2 panels. I had 12 volts at 95 amps. And from my power supply that's in back here, my 90-pound power supply. And then I had a array of batteries outside. And they provided much more than 95 amps. Oh boy. And I ran my ham amps are 12 volts. So when I key down, I don't know, 1,000 more, I need a lot. I could key down my CP with over 1,000 and run my stereo system at the same time. So much amps I had, or batteries I had. The 4 or 5 years I had them, nothing. And half of them were used. I'd swap them out with new ones. I'd buy the used ones and I'd throw them in just for storage. I knew that they didn't like voltage that much. They didn't like to go way up there. They're still okay for storage. And they were all marine, deep cycle. And then when I'd swap them out, I'd just take them to AutoZone and buy some of their marine blue tops. Not Optimas. Those are way too much money. Those are just not fucking worth it. If you had a nice race car or whatever. But in reality land, they're not worth it. Now, when you're doing this, I did that for CBs, okay? And stereo shit. Car stereo shit. Like this. If you're doing it for solar to run your house, it's not that far off, because with my setup, I could run shit in my house when the power was out. Did it all the time. And you need to look at a lot of factors when you're setting up for solar or windmill or bicycle, it doesn't matter. However, you're going to make the AC or DC current to charge batteries. You need to look at how many watts you need to run. This is you can use this for generators too. First off, generators. Don't run your computer directly off of it unless you got like a badass generator. They are dirty as all get out, and a lot of people fry their computers because they plug them into a generator. Same with your TVs. But I've gotten away with it. You just don't do it. The gasket sputter or whatever else, and the voltage goes, and then it goes, and then it goes. So don't do it. Using ups and ups and ups. UPS, ups, a battery backup, power backup. You put that in line. See? You put that in line, and it evens out the power. Those are about $100, $200. Okay? So, anywho, let's get back to figuring out power. You need to figure out how many watts you need. What are you going to run? You're not going to run a refrigerator forever. Okay, so, downsize to a small refrigerator. Okay? The convenience of having cold sodas, put them out in the snow. Whatever. When the power went off in my places, usually in the winter, you know what I did? I rolled my fucking refrigerator out the door. Right onto the porch. Why? Well, if it's snowing and 32 outside, guess what? So's my refrigerator. Push it out there. Fuck it. Now, you're going to need to figure out how many watts. Then, if you're doing generator, you want a generator that can do at least 1.5 times that. I know people say, oh no, you just need a little bit more. You don't want to push a generator to its max. It's when it starts putting out dirty power. You don't want dirty power going through your electronics. So try to do 1.5 times it. It's not that much more to go from a 5,000 to a 7,500. It's not that much more to go from a 2,000 to a 5,000. It's when you go from a 2,000 to 20,000 is where you get kicked in the nuts. So, yeah. You're going to want to have a generator that can run on multiple gas systems, propane and everything else. You gotta learn how to do all this shit. Because what if wrol? I mean, there's this whole subject right here could go on for 100 videos. It's so in depth of what you can do. But anyhow, I'll get past all that bullshit. Okay, for solar, same thing. You need to know how many watts constant you need to push the shit you want to push. Then you need to have the battery array to match that. You need to have the inverter to match that. And with the inverter, I say the same thing as the generator. You need to get the biggest inverter you can. You need to get the best inverter you can. You need to get the inverter that will allow a good DC voltage input. Now, I'll explain why. The cheap inverters you can find at the store usually will only allow up to like 14 or 15 volts in. But they will die. They will stop working at 11.8 volts. So when your battery array outside goes from 13 to 11, bink, oh shit. It doesn't know what to do. It shuts down. Now, if you had an inverter that was made decent and could take up to 20 volts in, you can go out and get Trojan 8-volt batteries and wire 8 volt to 8 volt to make 16, and then wire 16 to make the array. Okay? And then you go from 16 down to 11, you got a longer sweep. Okay? For your inverter to work. So you're going to get a lot more use of the batteries you have. Now, as far as batteries go, there are several different options you can go. I still will say either dedicated ones made for solar, because those ones are special. I can't remember the difference right off the top of my head. They're a deep cycle, but a lot of them are sealed. A lot of them you can run inside. A lot of them have gel now. A lot of them are like Optimas and shit. I still wouldn't run them inside. But or you could go down to a deep cycle, like a Trojan 8-volt or a Trojan 8-volt 6-volt combo will give you 14, which should be safe for most inverters. Even that's better than having 12, because the most that 12 will put out is about 13. So you got all these options. Then you got to look at chargers. You got to have a good charger. If you have a shitty charger that throws out dirty power to your batteries, well, then your batteries are going to die sooner. You need a way to constantly drain your batteries. You need to keep them working. You need to keep them alive. You need to learn how to wire your batteries. If you wire from one side, there's a whole theory on it. You got to learn how to wire. It's not just a series parallel deal, but where do you connect your batteries? Like me, I prefer to connecting from the middle of the pack. Some people connect from one end. There's been scientific data that says that's a bad deal, because then you're pulling hard from one battery and not the rest. I don't know. I like pulling from the center. I figure my penis is in between two nuts, so it must be right. You need to have the correct wires, the correct terminals, the correct everything. You got to spray them down and everything else. I did not have them in any storage, blah, blah, blah. I just had them up against the house. I ran 4 gauge up inside. I had fuse panels inside to take advantage of that 4 gauge. And the same thing here. I got 4 gauge sitting right here on my wall, and to run car amps and everything else, and I got a 95 amp power supply sitting, 100 pound power supply, not no cheap piece of shit, but to operate 12 volt what I need, because I do a lot of 12 volt shit. So when you get your battery array, you need to work it. Okay, you need to constantly use it and everything else, which will help you because it'll lower your electrical bills. Even if you use it just to operate fans in the summer or whatever else, you need to use it. Most battery packs, if they have a nice soft usage and a nice soft charge and everything else, they will last a long time. And they will get, most of them are rated for 5, 7, 10 years. So even at 5 years, if you have Trojans, you can sell those damn things and go buy another set of them. Just redo them every 5 years. You should be fine. Now, let's go back to the capacitor. Say your batteries all just go okay. First of all, in wrol, if it went out 5 years down, we're still in wrol and nobody's making batteries affordable within 5 years, and you still don't have your electricity turned back on, I'm still not saying this is whatever. I don't believe in this, but anywho, this is where people yeah, right. Okay, I'm going to offer a solution to the problem, and the solution is capacitors. 1 farad, 2 farad, but this is going to be a science experiment. You're going to need to know how many you need, and you need to understand capacitors. The greatest property about capacitors, well, here's 2. 1, they have no liquid acid. You can do this, you can do this. You can heat them with a torch and they go boom. Don't do that. They're dangerous as all hell. But other things, you need to know enough to figure out how much you need. And if you have to go to this point, You got to be realistic with your power needs. You got to only be operating certain devices. And the only reason I would say capacitors, and people will go, well, you could just go hook up to a solar panel. But then again, go back to understanding electricity in the generation type form. Is when you're making it, if it's not steady, DC current, it's like AC is okay, because it's alternating, it's swapping back and forth, alternating current. Okay, now if you have solar panels and you're generating power, what if a cloud comes in the way? That's going to affect the solar panel. Now, if you're maxing out the capacity of the solar panel and a cloud gets in the way, that could cause everything to drop just enough for your ham radio to get like 8 volts. And then all of a sudden the cloud moves and now it's got 13. That's just shit you shouldn't do with electronics. Now, if you have enough of these, and that's a number that you need to figure out, this will help study the current. It's not going to fix the current. It's not going to long-term store the current. This is just a buffer. It's a dam. Think of it as a dam for a current. It's going to stop it, it's going to fill it up, and it's going to wait there. If your supply cannot meet the demand, it's going to empty. Now, you need enough of a dam to offset the current needed for your device. So you need to do some math, you need to figure that out. I'm going to tell you right now, you need like a million of these. Not really, but you're going to need a shit ton of these if you think you're going to run a refrigerator. And you're not going to be able to run it at night. So you got to get that out of your mind. At this point here, when you can't get batteries anymore, and you're relying on this, you're only using electricity for the basics of what you need it for. Okay? Yes, I have run electricity using this in panels. Matter of fact, I've done this in cars. I've ran my cars. I won't get into that. But anywho, you'll need a lot of those. They're decently priced if you don't get a name brand. If you go get some ching chong 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 chong, might be able to get about 30 a farad. If you get into more name brand, you're going to get about 50 to 100 a farad. And you're going to need, don't get those digital whatever 50 farad little boxes, because those are bullshit. You get a real one. No lead acid. What do they call it? They have one out. It's called. It's a battery. A battery that drains as fast as a capacitor, and it's kind of like a hybrid. The thing about capacitors, the advantage that they have over battery is the amount of current they can discharge at one time. That's why they use these in camera flashes. They use these in stun guns and stuff like that, because the current, they can take it slow. Like when you hear the old flashes from the old 35 millimeters, you go, it's charging one of these to let it all out. It takes that long to charge one of these, and then it puts it out like nothing. And that's the one cool thing. That's why they thought these things fix stereos. Well, people would put these in thinking that they'd fix stereos, when in fact they can help, but they're not what they needed. People needed bigger alternators and better batteries. So this is a whole theory. This is why I don't get into all this bullshit, because there's people in the know that know how to do all this type of shit that will survive without any problem. But the biggest thing about wrol, if people want to go this far into it, is stop thinking of, do you need power? No. What do you need power for? What? TV? WRL, there's no TV stations. What do you need power for? To shave? Spyderco. Tenacious. $30. What do you need power for? The only thing is communications. It doesn't take much power to run that. Everything else, you can do without power. I didn't say it'd be fun, but you can. So, anywho, let me know if you want me to go in deeper on one part of this, but it's a lot of math that people need to do themselves. They figure out the theory and everything else. I don't want to. When you're dealing with this much power, when you have 12 batteries hooked up, you figure even if one battery can only put out 100 amps at one time, that's 1200 amps at 12 volt DC. You don't fuck around with that. You don't touch. You don't cross the streams on that. Because let me tell you about the flash that could happen with 1200 plus amps. And you're looking at more. Most of them are rated about 300 to 500 cold cranking amps. At least. You don't want to go there. So you need to understand the theories and power around it. But if you do, you'll find solutions to any of these problems pretty easy. Some of them are not going to be the ones you like, but you'll find them. Word.